So I don't know if any of you have ever done a rebuild on a 200 SRX head, and video may not even be needed, but I thought I would. I've got to rebuild mine from a crash yesterday. Had a servo go bad, and I thought maybe I would just, while I'm doing it, I'll film it and run through the steps, tell you what I'm doing. So just a couple of things that you're going to need up front. You're going to need a 1.5 millimeter Allen wrench, a 0 size Phillips head screwdriver. Other things I like to have is a little sewing machine oil, some anaerobic retainer, and some blue Loctite. I like to keep a little bit of a grease on hand. This is a lithium based grease. It's green, I prefer white, but it's just what I've got. And then I like to have a piece of glass. I've just got this mirror here, and I'll show you what I use it all for. So I've already got the head tore down, and the bearings are still in the bearing carriers in the frame. You can see this is from an earlier project. I've got it extended out. So the first thing that I like to do when rebuilding the head is, I check my main gears. I look at the teeth, make sure none of the teeth were stripped off, because most of the time when you're repairing a head, you've had a sudden blade stop, and anytime that occurs, you could strip the teeth off of your main gear, because the pinion gear on the motor is brass. And so it's harder than this, and it's like that for a reason, so that we strip these and we don't bend motor shafts. But in this case, I have to replace the main gear. I've got a new one here. The next thing is I like to check my my main shafts, and you do that by simply rolling it across a piece of glass. And what I'm looking for is some significant wobble up and down in the shaft. And this one has a little bit, but some of that could just be machining. So I really don't see anything particularly wrong with this main shaft. I'm going to run it again. Next thing you want to check is your spindle shaft. Now, the SRX spindle shaft is very small, and only about 1/8 of an inch of it actually sticks out of the main head block. So I would think the chances of actually bending this are slim to none, but we do the same process with it. Just want to roll it and see, and you can see this one perfectly fine, just like I suspected. There's nothing wrong with the feathering shaft. And then you kind of want to inspect your swash plate too. Sometimes the swash on any helicopter will have a tendency to the center part to separate from the bottom housing. There's nothing wrong with this. Check your balls, make sure they're not cracked or split. There's nothing wrong here. And then finally, look at the head block, and inside the head block you'll find your feather shaft dampeners. and they're, in this case, they're little O-rings. And I like to look and see if there's any tears or anything on them, and there's not. These are fine. Other than that, you really can't mess these blade grips up. It's got a thrust bearing inside of it. Anytime you have a bearing like that, it's a good idea just to check it. So I check my bearings by sticking the feathering shaft in and just turn it. I'm just trying to feel for crunching or anything that feels like it's out of round in there. And there's nothing wrong with that grip. There's nothing wrong with that one either. And really all the grips do in this one is they just take up end play because they don't move at all. It's a fixed pitch helicopter. Only other thing you have is the collar retainer pin. And so I try to, when I'm doing a build, I try to keep all my parts in a little box. Keeps my screws and things from getting out. There's a couple of things you need to know to pay attention to when you're rebuilding any head in particular. And I'll show you. These main shafts are extremely hard, but where they're drilled, you see where we've got a hole running through the main shaft. One of them holds the head, one of them holds the main gear. Because of the stress on the bolt running through the main shaft, you sometimes get a little bit of a burr. And that little burr on the outside of this main shaft can actually make it hard for the main shaft to slide up and down through the bearings in the bearing block. So what I like to do that's actually helped me out is I just take a knife sharpener like this one here. You can use a little bit of oil if you want, and all I do is I just go around the edges of the holes, because like I said, it's going to get torqued, and you're not trying to file a flat spot or anything in your shaft. You're just trying to take down the burrs. If you ever tried to pull one of these out, you know what I'm talking about, how hard the bearings are. It feels pretty good. Alright. So, you know, one of the first things in these builds is getting the main gear on. Now, I like to take a little bit of my lithium grease and apply it to my main shaft. I try not to get any right in here. That's where the retaining collar goes. And it doesn't really matter. There's a flat spot in there. It's going to get some on anyway. Let's put a good coat of grease on there. Because these things are surprisingly hard to get in these bearing blocks. You just kind of want to kind of work it in. It's going to be tight, and then come to the bottom bearing block just like this, and it's supposed to be tight. Don't be alarmed, but you see it's still burred a little bit. Once you get it through your bearing block, you see everything's free. It's just real hard at first. Put your main gear on. I find it easier just kind of give your main gear a turn. sometimes the main gear is a little hard to get on. I got it down through there now. Just have to line it. You can look through it and see the hole. So align the hole. And there's no need to Loctite this on there. And anytime you get a main gear, they give you a new screw. There's nothing wrong with my old 1.5. I'm going to use it. But you know, there's a good idea sometimes to replace them. There's just no need this time. So you just tighten it down. No Loctite needed here because we're doing. You've got a you know, a steel fastener going into nylon. So you don't need any retainer. I live in a barracks with 60 other soldiers right now, so you get all kinds of crazy sounds. We're deployed in Kuwait.
This is event 7. That's better than the Screamo. Listen to that.
Alright. It's a fine thread, so it's kind of rough getting in there. So this is where we're at right now. The next thing we want to do is we want to put our retainer in. Now you see how you get this up and down plate right here. I don't like any of this. This is just a bad deal. So what I want to do is I'm going to take some denatured alcohol and I'm going to clean the grease off of the shaft. That I put on there. So I really only need the grease to get it down through the bearing block. And now that I'm going to be retaining this, I don't want any grease on there. Alright. So we got our retaining collar here. Just want to back these, make sure these screws are backed out. We took it off, so I'm sure they're fine. Now here's the next step. I may get some riff on, because there's mixed opinions about it. You know, some say that anaerobic retainer can dissolve plastic, and you know, it can actually degrade the part. But here's the deal: this little collar will slide up and down on the shaft, and it's going to get loose. You have to tighten it over and over and over again. So what I like to do is I like to take a little bit of anaerobic retainer, put a little bit on a little Q-tip. You don't want to put it on the shaft. You want to put it just on the inside of the collar. It don't take a whole lot. The reason you don't put it on the collar, on the shaft itself, is because if you put it on the shaft and push this down, it's going to force that anaerobic retainer inside of your bearing, and you don't want that. So you put a little bit on the bottom side of this collar, and when you push it down onto the main shaft, your retainer is going to be pushed up into the collar instead of the bearing. So I just seat this in place, and all I'll do is I'll pull up on the main shaft, make sure the gear is meshed well with the bottom, seat the collar down. I line it with a flat spot. I do that by simply tightening one screw a little bit and turning it, and I can feel it. Right there it is. And just snug these down. Now I'm not saying that you never have to tighten it again, because it's probably still going to work loose a little bit, but it definitely does help. And then the next thing I like to do is I want to check my gear mesh between my pinion and my motor, and I can already tell that I have a little bit of a meshing problem. And so what I'm going to do is I'm going to slide the motor back just a hair. I've got thread lock on these because it's going into metal. So what I'm going to do is I'm going to take my soldering iron, make sure I'm getting contact on it, and I'm going to heat this up. And what that does is it releases the thread lock. Alright, check my mesh again. And what I'm looking for is, I had a little bit of skipping in it before, and now I don't have, and you can actually see the gear mesh better from within here. You look down through the top. So I want to make sure that my pinion is fully engaging. So I'm still off a little bit, and unfortunately the only way to get this any better is to remove the whole engine mount. And I believe that I'm going to do that. So I'm going to stop the tape a second. But basically what I'm going to do is I'm going to remove the mounting block out of it. There's 2 retainer screws on the top of it, and I'm going to slide it just a fraction back, and I'll get back with you. Alright, so I'm back. I slid this bearing block back a little bit. Got a really good gear mesh now, and just put some Loctite back on my fasteners back in the engine mounting block. But it's perfect. I have no in play. I like it. I'm happy with that. So my tools back over here. Alright, so the next thing that we want to put on here is our swash plate. And now you can go ahead and put a little grease back on your main shaft again, and couldn't put swash back on. Now, one thing you notice is when I get in here to this anti-rotation bracket, you know, you should really loosen it, but you can just bend it back a little bit and it slides right on. That's the way to do it. Alright. Y'all may fuss at me for that, but there it is. It's flimsy. It slides back and forth just fine. And then I always kind of wait till last to hook up my servos because they are geared, and I don't want to apply any real pressure to them, you know, and hurt them. So next thing we're going to have is our head block. Get it in place, and then just simply spin it to line the holes up.
It's not under my bunk, that's the problem. Rolling from underneath your bunk.
So there it is.
It's not under my bunk, that's the problem.
And then we'll
Fix it.
secure the head.
Woo! What you doing there, man?
These guys are crazy. Alright. Next thing I want to do is put in my dampeners, and for that I use a little different grease.
You change your uniform every single day. No, your pizza. Yeah, dude. You don't change your uniform every single day.
I use a non-petroleum based silicone because these are petroleum washers, and or yeah, these are rubber O-rings, and the non-petroleum based stuff's just better. It doesn't break them down. So put the dampener in there. Dampener. Like that. Alright. Then comes the feathering shaft.
Fire, do you have this yet?
See, it doesn't stick out there very far at all. So I was telling you earlier, I think the chances of actually bending that are kind of slim. And then we have two little shims. And if you notice, one side of it has a slightly raised part. And what you want to do with that is take and turn the flat side in towards the dampener. Raised part this way. And it's designed that way so that the raised part, which is slightly smaller diameter than the non-raised part, is to allow for the shim to ride on the inner side of that bearing, which, like we talked about earlier, this doesn't move. Okay, next we're going to put our grips on. They're not hard to put on. Just want to make sure that the fastener side, the little raised side, goes down. Right. Again, raised side goes down. The two halves just slide together like that.
What if it doesn't work? Can you just say it doesn't work and give it back?
And then they use a retainer,
That's the only reason I got it.
a fastener.
Bullshit. I lied. Huh? It actually makes a lot of sense. That's insane. Dude, the video has a guy at the very end of this video. He's got this t-shirt on.
Dumb me. Sorry. Used to working on the 450. He uses a very small retainer, not a 1.5. Alright. And then this was in here. Alright. Next step's pretty simple. I go ahead and put upper control links in. They're really easy to get on there. Like that. And then I simply put my adjustable lower control links in. And that's pretty much it, except for the grips, or the blades. We could talk about those real quick. The only thing that you need to really remember with these blades is that you don't want to get these overly tight. The rule of thumb typically is that you want your blades tight enough so that when you hold the helicopter on its side and you bump it, the blades can free fall down on their own, so you don't have to bump it too hard. The SR likes the blades to be a little looser. Now I do balance them. I put a little tape under the bottom to balance them, and then I follow the tape up with a little bit of glue. I do a couple types of balancing. I'll actually put a I'll put a main shaft and roll it, and I'll find my static position, which is the place where the blade balances in the center, which is right in the center of my tape, and that lets me know where I need to add my weight, because I want to add weight to the center point so that I affect the whole overall weight of the blade, and I don't create a moment around the head grip, which this can create vibration. So whenever you balance your raise, you want to find the static position on the blade, balance it right there. That's where I add my weight, and then I can put this in my blade balancer, tighten it down, and then add weight to the lighter blade at the spot where it needs it, which would be the dead center of the blade. And then I've got a blade that's both balanced dynamically and statically, and it will run the smoothest. Yeah, I get to about where I can feel where the blades need to be. And now when I take the helicopter, this one's a little bit too loose. I'll turn on the side like this. I should be able just to bump it. This one's a little too tight. Little shake down, and they should fall on their own. They just about stay up, but they'll want to fall. This one's a little too loose, and it's not overly critical, but that's about perfect right there. And that's how you rebuild the head. We'll take it outside and give it a test run.